Hello 108 students, Mr. McHugh back here with you on page 3, working our way on section 5.3 here, and we're going to work on a concept that's going to take us here to something called the composition of functions. And I wrote up here, think of nested functions, and we're going to see some new notation that it's going to take a little bit of while to get used to it. So what happened here is composition of a function, and you're going to see two functions with the letters, and they're going to put an open, like a degree symbol here. Okay, now it does not mean multiplication. That's the hardest part of this. It's not an operation. They call it a composition. The composition, think of an operation. I don't know if that word will help you, but that's how I try to think of it. And what it is, it's nested functions. You're going to have an inner function. You're going to evaluate the first function relative to x. You're going to take that output and put it as input into the outer function. Okay, so another way to write that notation is, here's f of x, here's the inner function like I mentioned. You take that result and it feeds into, look at the outer parentheses, the input into the outer function, and you finally get that final result. Okay, now you're like, oh my word, what is he saying? What's he talking about? If you read an excellent description of this is on page 287, and we're talking about the pair of genes for sale to grasp the concept. Okay, and here's the idea. A lot of you guys like to go to Kohl's or wherever you like to go shopping, and you hear there's a $40 pair of blue jeans is on sale for 25%. You're like, great, that's awesome. And then on the radio commercial they mention if you purchase the jeans before noon, which means you got to get up early, the retailer will offer an additional 10% off. What is the final sale price of the blue jeans, not counting tax? Okay, now the book says you might be tempted to say, oh, 25% and 10%, I'm going to take 35% off of the $40 and get my answer. And 35% of $40 is $14. Subtract it from 40 and you get 26, and you go, that's my answer. That's how much I'm going to save. And you get up to the cashier and you find out you're in for a little bit of a disappointment, and here's why. To find the correct value of it, first you got to take your $40 and you got to take your first original 25% off, and think of that as being your inner function. Take 25% off of 40, which is $10. So 40 minus 10 is 30. Okay, now that $30 is what you would have paid, but you're there before noon. Now you take that output from the inner function and take it into input into the outer function, which is to take an additional 10% off. What's 10% off of $30? That's $3. So 30 minus 3 is $27. So you are going to pay $27 for the jeans, not the $26 that you originally had hoping for. Okay, so study that example. That's a great analogy to the inner and outer functions and the word composition. Think of that as a degree symbol like I mentioned before. It is not multiplication. That's the hardest part. Think of it as an operation. Inner function, outer inner function, outer function. Okay, I can't talk. Okay, so you go, what's he talking about? So these examples aren't too bad. Let me try to walk you through example 5 here in my notes. First function, f of x is equal to x squared. The g of x function, the second one's x plus 3. And they go, what is the composition of f of g relative to the two functions? The order matters. Okay, make sure you remember that. The order matters. The inner function is going to go first. Okay, so, and they are going to have you evaluate it when you've got x is a value of 4. So you take g of 4, which is x plus 3. You're going to substitute 4 in for x. So 4 plus 3 is 7. So you've got f of 7. Okay, that's the function of there. Now you're going to take that 7. That's the result of the inner. You now are going to take it and put it into the outer function, which is g of x, and you're going to substitute 7 in for x squared. So 7 squared is 49, and that's your answer. The final output is 49. So f of g, f composition of g relative to 4 is the final result is 49. Okay, think of that double sales tax sale that we talked about before in the genes. Okay, and I mentioned that the order does matter. I'm going to prove that to you here. Instead, I'm going to take the exact same problem, except this time we're going to put the inner function is going to be the f function relative to 4, and that result is going to go and be input into the outer function of g. So let's see what happens here. So take the f function, which is x squared, and plug in 4 for x squared. 4 squared is 16. That now becomes the input into the outer function of g. So g function is x plus 3. We now are going to put 16 into it. And so 16, well, you don't put it into that. Put it here. 16 plus 3, you get 19 as your final answer. Okay, so there's the proof that the two are not equal. 19 was the one answer. The other answer was, what did we come up with? Oh, excuse me. Sorry, what was it? 49. So you could see 49. Oh, geez, 49 does not equal 19. Okay, that's the idea. You practice these for a couple times. They're not too bad. You just got to remember inner function, input the original x into it, get the output, take that answer and put it as an input into the outer function. You'll get your final output. Okay, Mr. McHugh saying adios on page 3 here of our class notes. We've got page 4 to cover here. We're going to do some graphing of polynomial functions, so we'll take a look at that. Okay, so I'll see you here in a little bit, and we'll take care of page 4. Okay, goodbye.